You spend 2 years and $50 million building a state-of-the-art system. The code is flawless, the hardware is bleeding edge, but on launch day, the system crashes hard, not because of a technical glitch, but because users have no idea how to operate it, and the product doesn't solve their actual problem. This comic illustrates a well-known phenomenon in engineering: project failure caused by a massive gap in communication. Look at what the customer explained they wanted, compared to how the systems analyst designed it. Because modern development teams operate in isolated silos, each group filters the initial idea through their own assumptions. By the time the code is written, the original intention is unrecognizable, leaving the user with a useless tire swing. To prevent these cascading failures, teams rely on establishing clear requirements. A requirement is a highly specific, documented statement detailing exactly what a product must do, how it must perform, and the conditions under which it will operate. Establishing these parameters early is the only way to ensure alignment across disciplines. If you skip this step, the engineering team is coding blind, burning through budgets to build a solution for a problem that doesn't actually exist in reality. You cannot write accurate requirements sitting in a conference room. You have to enter the problem space. That means deploying into the actual environment where the user operates, navigating the noise, constraints, and daily chaos they face. One highly effective field tactic is contextual inquiry. Instead of conducting a formal interview, the researcher acts as an apprentice, shadowing the user as they go about their daily work. This reveals the actual habits and workarounds people use, rather than what they claim they do on a survey. Teams also deploy probes. These are physical objects, like customized diaries, cameras, or early technology prototypes, left with users in the field. They prompt the user to log their daily interactions and frustrations, surfacing deep insights into their workflow. Once that raw field intel is gathered, it has to be structured. The baseline elements are functional and data requirements. Functional requirements outline the mechanical actions the system must perform, while data requirements define exactly what information needs to be captured, stored, and retrieved. Then come environmental requirements. A product must survive its deployment context. Does it function in a loud, vibrating factory? Does a hospital ward require strict data privacy? These rings of constraint dictate the product's physical and digital boundaries. Security protocols are particularly vulnerable to these environmental realities. If a system's defense mechanism is too cumbersome for a fast-paced workflow, users will simply circumvent it, taping passwords to monitors and instantly compromising the network. Systematically sorting observations into functional, environmental, and security requirements allows the team to map the exact operational hazards the product will face upon deployment. But a spreadsheet full of categorized data points is sterile. When a developer is deep in the code at 2 a.m, a rigid list of constraints doesn't provide context for nuanced design decisions. The solution is to synthesize that data into a persona. A persona is a realistic, highly specific user profile forged directly from the field research. It gives the target audience a name, a set of defined skills, and precise motivations. Here we see how that persona is put to work. Designers drop the persona into a scenario, an informal, narrative story detailing exactly when, where, and how they will interact with the system to achieve a specific goal. These narratives can even escalate into design fictions. By storyboarding interactions with emerging technologies, teams can pressure test the ethics and social implications of their product in advanced contexts before a single circuit is wired. Personas and scenarios translate cold technical metrics into a tangible human narrative. They keep the entire production squad aligned, ensuring everyone remembers exactly whose problem they are solving. Once a scenario is validated, that narrative has to be formalized. A story about a user booking a trip is great for team alignment, but programmers need strict step-by-step logic to actually build the software. That critical transition happens through use cases. A use case is a rigorous blueprint that strips away the narrative fluff and documents the precise interaction between the user and the system. At its core, an essential use case maps out a sequence of actions. For every specific intention a user executes on the left side, the system must respond with a designated responsibility on the right. The user enters a destination. The system requests their nationality. This establishes the normal course of interaction, the ideal sequence of events when everything goes exactly according to plan, and the user inputs all the correct data. But systems rarely operate in ideal conditions. The documentation must account for alternative courses. If the user enters an invalid country name or the network drops the connection, the system needs predefined logic to catch the error, alert the user, and loop back to the previous step. By mapping out every primary interaction and every possible error state, this documentation becomes the definitive bridge between user research and software engineering. The path from a vague idea to a functioning product is paved with requirements. By moving systematically from field probes to humanized personas and rigorous use cases, a team guarantees the final code directly answers the given mission.